Navin, you can start next.
Okay. Okay. So uh, yesterday we have discussed Sqoop. So Sqoop is a data ingestion tool that extract data from RDBMS sources and ingest data into HDFS. HDFS means data lake. Okay. So MapReduce, we discuss limitation of MapReduce. That MapReduce is so one constraint it is developed on Java. So developing Java job for each and every task, even for simple analysis, it's not feasible to write the lot of code and deploying it. So that is the one challenge. We need data. If we are dealing with the data, we need SQL. Okay. Another challenge was that MapReduce support less file formats. Means it has support for text file format, but if we change the data source to flat files, Excel, CSV, or databases or any other file format, then we need to customize a lot. So in that case, we need to write Excel input format, database input format class, and then record data class also we need to develop. And mapper and reducer is always there. So a lot of customization required if we are dealing with varieties of file formats. And also there's no batch processing available in MapReduce. So these are the limitations. And also one more thing, it's process data in disk only. And disk processing is slow. That is also a challenge. So that's why Hadoop provide all the ecosystem tools so that we can easily interact with HDFS. So here, first tool was Sqoop. So here in the diagram we can see. So if we have a source system, Oracle or RDBMS source, so then we just need to write the Sqoop job that will extract data from the source. That job will be auto converted into MapReduce because HDFS understand MapReduce only. So that uh, code generation activity happens within Sqoop server. And once this Sqoop job is converted into MapReduce, then it's uh, submitted on the master, and then it will start the parallel processing. Okay. So there we discuss a lot of tools in Sqoop. So yesterday we discussed full import using import. Now we have others things available. So import all table, export, code gen job. So we'll discuss all these today. And there are some concepts also that Sqoop provides. Okay. So let me connect with the server. So here just fetch the IP. So this is the IP. Now connects with putty. 8.1.42. So password is Cloudera. I hope everyone installed Cloudera on your machines. Okay. So now it's connected. So verify Sqoop. So Sqoop server is available. We can verify Sqoop using Sqoop version command. Sqoop is here. Now, um, so let me execute import again. So this is my HDFS, and here we have created these directories. Um, okay. So open one more session. Now and open the source system. Source system is MySQL. Now here use database MySQL. Two tables. So this is the table, employee table. Okay. And we import data from this table into data lake. Hadoop. Okay. Uh, this one will get in one call. So duplicate session means we have here we have Sqoop and this another session here I have opened MySQL. So this is my source data. This is MySQL window and this is where I'm running Sqoop. So now Sqoop import connect with the MySQL source JDBC using JDBC. My database is running on local. This is my database and the username root, password Cloudera, and the table that we need to import. Table is employee.
Naveen, is it possible to zoom a screen little bit because the two participants are not able to see properly?
Okay, let me check.
Yeah, please.
Is it better now?
Yes, thank you.
Okay. So we can see here our MapReduce job is running, but we have submitted the Sqoop job. That Sqoop job is auto converted into MapReduce. So right now this MapReduce job is running, and this job is submitted on HDFS on the master mail. So it's completed. Now verify whether data is ingested. We can verify from CLI from command line as well. So we have Hadoop file system -ls. So using this command, these are HDFS command. So we can check the directory. So this is our directory. So Hadoop file system -ls user Cloudera employee directory. So these are the part files because it's a parallel processing tool. So this mapper is for first row. This is for the second row. So as we know that our data is very less. So there is no need to run two mappers. We can execute our job using single mapper also. And if single mapper executes, it will be faster than the two mappers because of this small data. Okay, so let's verify the data first. So hello file system, and then using cat command, we can check deploy and then open this part file. So this is our data. Does it automatically create mappers? Yes, it automatically creates mappers for us. And by default, there are four mappers. Okay. Now we can control these mappers based on our data. So that I will explain in this controlling parallelism. So controlling parallelism means because right now two mappers runs means two threads are running and two threads process the data. But as I said earlier, we have 128 MB is the default size that a mapper process effectively. So for a one mapper, 128 MB data is required to be processed. But here in our case, our data is very small. It's hardly two rows only. So this data for this data, one mapper is enough. Okay. And by default, Sqoop provide four mappers. So we can control these mappers. So let me execute this job again so that these job uh, can be optimized. So here we are doing optimization. We are applying optimization technique. So based on our data volume. So uh, hyphen mapper one. Okay. So this is how we pass a mapper, and because we already import the data, so let's import the data in another directory. Give a target directory, user Cloudera, deploy dir. This time that your data will be inserted into this directory, and your single mapper will do the full execution, full ingestion. So let's submit this. So again, this job is converted into MapReduce, and here we can see in the logs that it generates the Java code here, the MapReduce job. Once this job is finished, we will verify this location and see what uh, kind of code it generates automatically. So our job is running, this MapReduce job is running. It's data is ingested. So verify your data. So our data is ingested into this directory. So we have one part file only. So using cat command, we can check the part file. And now this time it has two records because single mapper process both the records. Okay. So this is this is how a ingestion job, or you can say scoop job, works internally. And check the code, what kind of code it generates. So mappers are like bucket. No, mappers are threads that process data. Mapper is not a storage. They, they are processors only that process data from source to target. Okay, so go to this. In the logs, we have seen that it generate the code. So it provide a location. Where is that location? This one. So this job and this location. This one. So go to this directory, temp scope cloudera, temp scope cloudera, compile, and here we can check 90105. 90, this one. And if we go inside this, we can check this is the generated code. So here we can check this kind of code it generates. So Sqoop automatically generates the code for us and it do the ingestion. Okay. Now, next is export. So ingestion, this full import is done. Now import all tables. So if we apply import table, import all tables, so it will import the whole database. So 1 minute. So here show tables. So these all are the tables available. So if we write Sqoop import all tables, so write Sqoop import all tables. Connect ADVC MySQL. The data was already on the HDFS. Which data? We ingest data, employee data. Yes, we ingest data in HDFS. Now, what about other tables? Now, for every table, do we write a single separate job? So we in one job we can import or the full database, yeah, all the tables in one go, or using one job. So that we can do using this command. I'm not executing it, but I'm just showing how we do the how we import the full database. So here this time we will not provide any table. Yeah, so that is the command. There's no need to specify table. It import of full database is same every time. So yes, because right now we are connecting with MySQL, but if your database is changed, let's say Oracle, Postgre, then you need to provide that database. And also, this is a repetitive thing. We are writing this thing again and again. So what we can do, we can uh, we can remove this using a options file. I will explain this options file. So, so your import and import tables, import tables is done. Now let's touch base this options file so that there is no need to write that connection string again and again. So what is option file? Option file is a script through which we can uh, we can remove all the common or repetitive parameters in a script. Okay. So, how we create the script? So just create a simple text file uh, like this, and here import. Then this is the key connect, and this is the value. Okay. Now username is the key, root is the value, password is the key. This is the value. Now we are passing these parameters in a file, and we will give reference of this file. This file is in desktop. So let me um, use this file Sqoop option file. Let me check the command. Option file. This one. Okay. So Sqoop option file hyphen options file. Okay. Options file and give the file path. So home, whatever. On desktop, we have created a file Sqoop script, and then we give the table name that we want to import. Okay. So as I said, this is a full import, so we need to clean up the files every time. So what we can do, do file system hyphen ls. So just delete the file, delete the directory, remove and remove this. It's a directory RMR. Mm, Okay. Now this is deleted. Now we can trigger this yawn. So here we can see we are not writing any connection string. That connection string is separated in a file. That it's in this file we have put this common, you can say, connection string, and this command executes in a similar manner as we did earlier. Okay, so this job is running. For full import, directory must be empty. Yes. So today we'll discuss incremental import. That then this challenge will be solved. Okay. So data is transferred and we can verify. Room file system -cat user Cloudera and deployer. File extension are not required while we create files in Hadoop. No, because it's a file system. We can dump file data of any format into data lake. Okay. Extension doesn't matter. Okay, now data is imported. So that is option 5. Okay, this one is done. Now next is export. Export is the reverse of import. So export data back to the MySQL, or you can export to some other data source. So let's import back to MySQL. So here we show the content of option file. So this is the content of option file. Import, then connect. This is the connection string. Then the key username. This is the key, the password key, and its value is this. This is the content of script file. Understand? Okay. So now the reverse of import export process. So let's create one table. Let's create a backup table. So create a blank table with a similar schema. So it has a primary key. Okay. Okay. Employee table is already there. Create a backup table. Okay. Table is created. Now do export. So export command. Where is the export? This is the export. Okay. So the same command, scope export, and then the connectivity. But in the scope script, we have mentioned import. So that's why I'm not using that script. We need to remove import from there, and then we can use. Okay. They will be safe. Now, here we need to provide export directly. So export hyphen dir. We cannot write both import. No, so that data will be appended here. So uh, you need to dynamically pass that value. So using scheduler, we can dynamically pass. So export directly, the directory from where we need to export the data. So employee directory, and the table where we need to export data back to. So employee backup. Now execute. There's some issue here. Um, export directory. Hmm, something is wrong. I forgot to mention the connection string. Now it will work. Now this job is exporting data back to MySQL from HDFS. Okay, so data is exported back. So we can verify the data in our table. So data is successfully exported back to MySQL. Now next is export is done. Next is validate. So validate is used for uh, data integrity. So data integrity means we need to check whether data is successfully transferred from source to target. So if in our source we have 100 records, so we need to validate in the target system all the 100 records are successfully transferred. There is no missing records, because sometimes what happen due to some exception or network issues, sometimes some records are missed when data is transferred. So that we need to ensure that in both source and targets, um, your data is successfully transferred, nothing is missed. So that we can do using validator. So the entire process will be taken care by resource manager. Which process? Which process you are talking? Yarn is a cluster manager. So cluster manager allocate resources. Right now on our HDFS, we are submitting single job at a time. If we submit multiple jobs at a time, so it split the resources to multiple jobs. That is the resource manager thing, the yarn. So I will explain yarn later on. It's a resource manager, or you can say cluster manager. So now the validate. So whatever command you are executing, just do a validation check. Okay. So um, uh, by default, we have row count validator. So we can do a row count. So let me execute one command. Uh, let's validate this. Validate. We need to add validate at the end. So it will, okay, something wrong. Again, the connection string. Hmm, no such tool. Uh, 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 Sorry. Sqoop export. After export, we need to add connection string. Now it's working. So this time it will turn on the validator, and that validator uh, validate both source and targets using row count validator and provide us the result. If row count doesn't match, just throw an exception. So using a validator. So at the very end, we will see what all pre-built validators are available. Mm, okay. Yes, okay, this job. So data is imported. See, you can what it is saying that because data was already there, so it's saying that export zero record and job got failed. Okay, for import as well. Yes, do a validation. So let's do this. Scoop hyphen hyphen options file, and then after option file, your file is in this directory. Stop scope script, and then the table. It's a full import, so we need to clean up our directory first, and hyphen hyphen validate. So we are adding validator in an import command. So first clean up the resource. Uh, now, submit the job, and this time you'll see the validator runs with the import process. So you can validate any job because Sqoop is an ingestion tool, and you are ingesting from source to target. So you can do a match of records in both. Okay, so we can see uh, this row count validator, import and validation done simultaneously. So validation happens after the import. What it validation is comparing both source and target results. So once job is done, then only it validated, and you can see at the very end, it just do the data integrity check using this validator, and it's showing the success. Okay, that is the job of validator. Okay, now next, this is done. Next is job. Okay, now uh, and whatever commands we are running, we can say these are the jobs, and I want to trigger this job in daily basis. Okay, so if I close the putty session, then these jobs are lost, and I need to rewrite these commands again. So better is to save these jobs, save these commands in a job. So Sqoop job, first check the jobs available. Import and validation we can do in single command. Yes, I do import and validation in the same command. This command C, import is also here, and validate is also here. So now Sqoop jobs. So okay, I need to check Sqoop jobs. So Sqoop job list to check the jobs. So now it will show the all the jobs available in the Sqoop server. Right now there are three jobs. So we can create our job, Sqoop job hyphen hyphen create um, this command. So Sqoop job, create, and you can give a name of your job. So we can say ingestion to job, and then the import, it's an import job. Okay, so it will create a job for this command for the import. Now the job is created. Let's do job. You can list the job using Sqoop job list. Sqoop job list. Okay, now it's showing 4 jobs. Now these are saved permanently. Now we can run this job, or and before running the job, I want to inspect what kind of job it is, whether it's an import job or an export job. So that inspect we can do Sqoop inspect. Yeah, this command Sqoop job hyphen show and the job name ingestion to Sqoop job again. Okay, so what I said, this is an import job, import command, and I'm executing these commands uh, in this putty session. So if I close my putty session, these commands will be lost. And when I will start the session again, I need to rewrite these commands. So better is to keep these commands in the Sqoop server permanently using a job. So we can create these jobs using this command, Sqoop job, create, give the job name, and inside job, this import command is saved, or import job is saved permanently. Now, these jobs are available here. We can see the jobs, and we can run these jobs whenever required. These are permanently saved here inside a Sqoop server. So this job I have created, and I knew this job is an import job. But what about other jobs? There's my job, test job. So I just want to inspect. So the database table we inspect using describe. Using describe command, we check, okay, this is the schema of the table. In a similar manner, we can inspect the job and we can see, okay, it's a Sqoop job, it's an import job or a export job, from the which source data is it fetching the data, and from which source it's connecting. So those sort of details we can check. So let's do an inspect using this command Sqoop job hyphen hyphen show. First, check this job ingestion to job. So when I execute this, it show the details of this job, and these are the details. So the job name is job ingestion to job, and tool is the import. Okay, it's an import job, and this is the connection string from this source. It's fetching the data, and what table we are importing, that is out somewhere mentioned. Where is the table name mentioned? Oh, yeah, this is the table name. Okay, and on this directly it's generating the code. Okay, so these are all the default properties that Sqoop runs. And as I said, Sqoop is also developed on Java. Internally, it's Java only. So these properties runs, or these classes runs in the background whenever we are doing the ingestion, or uh, or doing ingestion from source to target. So now we can execute jobs as well. So how we can execute? We can execute using this execute command. So Sqoop job execute, and you can give your job name. So ingestion job 2. Let me check first. It's importing employee directory. Um, Database is this. Okay. Let me create one more job. Mm, Table. Table is employee. Database is MySQL. Okay. Job is 3. Mm, Okay. So this job is created. Now execute the job. So to job, execute, ingestion, job 3. And we already imported the employee table data. So just clean up this directory. Hmm. Ingestion job 4. Okay. So we can execute these jobs using this command. There's something wrong. Performing job operation. What happened? Job. Hyphen list. Okay. I hope you guys understand what I'm trying to do. So we can create the jobs and then we can execute the jobs using this execute command. Okay. Ingestion 3. Okay. Ingestion 3. Ingestion 3 job. Yeah. Yes, now it's working fine. Okay. Now next concept is uh, uh, job part is done. Now next is meta store. Now whenever we are whatever we are performing in Sqoop server, so its metadata is maintained somewhere. Okay. So by default, in Cloudera, they have provided HSQL. HSQL is a memory database. Okay. So it stores metadata in memory. But in real time, and when we are working on the projects, so we use RDBMS like um, all the RDBMS databases, whether it's Oracle or MySQL. So they store metadata information. Metadata is data about data. So information about the jobs, and when we run these jobs, so how much data process. So all every information is stored in meta server. So let me start the meta server. So using Sqoop meta store command, and we can see it's it's showing that it's using HSQL uh, database. So that is a memory database, and here in this location, this on this path, your metadata is it's consuming the metadata. Okay, and this server is running on this port number. Okay, So we just need to be aware, because when we submit multiple jobs, then it's not able to append the data. So we need, in a real-time environment, we need RDBMS source to store the metadata information. Okay. So that is around the metadata. Now, uh, next concept is um, this list databases. So before doing the import, so I want to validate uh, the data in a source or do some analysis. Because right now I have the access of MySQL, but in real environment, sometimes we don't have access. We have access for SQL Sqoop only. From Sqoop, we need to check how much data is there, what is the data volume in the source, basis on the data volume, how much mapper I need to use in my job. So that all things you need to validate. So for that, what we can do, we can write Sqoop um, um, eval means the evaluate. We are evaluating our data before import. Okay. So validate, then connect to your MySQL server. These are MySQL details. And then hyphen query. So using this query arguments, we can verify. 1 minute. Let me open hyphen query, and then we can check. Okay, what is the record count? So select count of star. Um, on table is employee. So we are doing the valuation check before doing the import. There's something wrong. Uh, mm, okay, what? Yes, okay. Now it's fine. So it provided account. We can check the number of columns, number of rows, the data size, and these details we can evaluate before import. So that is the purpose of eval. We can list down databases using list databases. Okay. So it's just under valuation. Now code gen is used to generate the MapReduce code. So right now, whenever we are submitting our jobs, so first our job generates the code. So every time we are submitting the job, so we see that it generates the code in here, and then after generating the code, it do a compilation check using compilation manager, and then where is the compilation manager? This is the compilation manager. Here, this is the CodeGen tool, the compilation manager. And after compilation manager, the job is submitted using job submitter tool. So there's a tool that submit this MapReduce job, uh, job, job submitter. Hmm. Okay, so these are the tools that do the code generation, doing code gen tool generates the code, compilation manager do the compilation, and job submitter submit the job. So now I want the code only. I don't want job to be submitted. So you can write Sqoop code gen. Okay. So let's say I want to generate uh, the code for this command. So we just write scoop code gen. Okay. And then scoop code gen. In this, something wrong in this code gen, scoop code gen, and then so it's just for code generation only. Okay. It's not submitted the job, it just generate the code. Okay. Now, next is so all these tools we have covered so far. Now there are some concepts available. So first is the default mapper. So by default, Hadoop launch four mappers. So if we check, there are two rows. Let's insert more rows in our database. So insert into this table, employee, into okay. So one more row inserted. Let's insert one more. XYZ, ABC, XYZ. Now check the rows. So let's start from employee. So there are four rows. So this time, Sqoop will launch four mappers. Okay. I knew that this data is very small, so one mapper is enough. But let's check how many mapper Sqoop launch for this particular job. Let's insert one more record and then see. And I knew that it will launch four mapper only, even if we have five records. So one mapper in just two records and rest other insert single record. Four, three, six. Now we have five records and now do ingestion. So Sqoop import let's import in some other directory. Let's say employee default. So this time we are ingesting data into this directory. Let's check how many mapper launch internally. The job is still running. Okay. So now check how many number of mappers launch. So root file system -ls and default mappers is a directory where we import our data. So here we can see 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Means 5 mappers. So let's insert one more and then check. Because here in this cloud Sqoop version, there are five mappers. Because in every version they set the default. So they insert one more. You see, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now this is inserted. Run the job and now say 1, 2, 3. So because for every records it's launching a different mappers, and there's no need to launch separate mappers because our data is less than 128 MB. One mapper is enough, but we need to check we are checking the default behavior uh, of Sqoop, that by default how many mappers it launch. And then once we check the behavior, we can control this behavior using this controlling parallelism. Okay, so now ingested. Now check how many mapper launched this time. So okay, first 1, 2, 3. Now this time, see 4 mappers only. So this shows we have six record. So one mapper is processing 2 records, and other ones are processing 1 record. So if we check uh, default mapper this, and one mapper is this one, first mapper, it's processing 2 records, and this one is processing one, this one is processing one, and the last one is processing two. You see 4 mappers with 6 records. If you have 10 records, 20 records, still it will launch 4 mappers only. But what is the limit? How much data a particular mapper can process? And I explained multiple times that 128 is the maximum limit. So now for this particular job, I don't think we need so many mappers. We need single mapper only because data is this data can be handled by one mapper only. Okay, so that's why now this time you will see there is a performance improvement. Your job will execute faster than the jobs that we executed earlier, because here this time a single thread will be launched, single resource will be utilized. Okay. So now we can see this time we will have single mapper only. Yeah, we have single mapper, and if we check the data, it has all the data. How to know size of the table that we import? No, you don't want to check the size. This everything is handled by the Sqoop. It just the data volume approx. These are approx numbers. There's no hard and fast limit, but approx we need to be aware. Okay, we have 100 GB data in our source. So if we have 100 GB, then how bigger cluster is required, and how many mappers will be launched on our cluster, and how much time a job is executing, the processing time. So these all things we need to check. But again, the senior resources in the organization, they do this activity one time, just check the resources of the cluster. They provide those optimization parameters that we need to pass. But if you want to calculate, for calculation, as I gave the formula yesterday, that if you want to check how many mappers we can launch on a particular data node, so that you can check based on the CPU size. But then how we decide the number of mapper without the size? I told you size, we knew how much size in a database, you can check the size. But again, these are approx numbers. It's not hard and fast. But understand the concept of parallel processing first. That is more important. And how we control the parameters. That is more important. Okay. Now, next. Next is boundary query concept. This is very important. So there are two types of boundary queries. Inbuilt boundary query. So when every time we are running our job, so we have controlling parallelism. We already discussed that how many mappers we need to pass or we need to launch in a job. So that we can pass using this argument, and this number is based on the data volume. Okay. Now default mappers, we knew 4 mappers, and we can increase or decrease using the second parameter. If I pass 20, it will launch 20 mappers. Okay. Now inbuilt plus custom boundary queries. Okay. So first check the boundary query that Sqoop executes every time. The inbuilt one, this one. You see here, there's a query here. Select min of ID, max of ID from employee. So in every job, we have this query. So let's copy this and copy this on your source. So Sqoop fire this query on the source and is check the record count. Okay, minimum values is 100 and max value is 105. So that is the range. So Sqoop get to know, okay, there are 5 records. Basis on this range, it do a splits. So if we see after the boundary query, where's the boundary query? Um, where is that query? Yeah. You see, after the query, it create the splits, and number of splits equals to number of mappers. So it launched the mappers and distribute the task. So that is the inbuilt logic we have um, in Sqoop, within Sqoop only. So this boundary query, check the boundary means the range of the data in the source, and then do what splits, and then basis on the splits, it launches the mappers. And these mappers we can control using our uh, the parameter that I show, the mapper one argument. Okay. So now the custom boundary query. So let's take one example. Um, this one. So let's create a purchase table first. So purchase table, two tables, check whether this table is already there. Purchase table is there, drop this table, drop table purchase. And now create purchase table. The table is created. So describe purchase. Okay, so there are four columns: purchase order ID, product name, quantity, and price. Okay, now insert some data in this table. So insert, and we are inserting three rows. What happened? Purchase table values. So okay, this is the corrupt. Let's change this columns. Okay, now it's inserted. So select start from purchase. Now import this data into data lake, into HDFS using Sqoop. So let me check whether this table is already there. Your table is there. Delete this. Now write a Sqoop import command to import. Single mapper is fine, and there is no need to give target directly. And table name is purchase, and rest other things are okay. So now I have executed this import. Okay, 1 minute, 1 minute. So remove mapper. Just do a simple import with default mappers. So it failed. Import failed with this reason. Can you guys guess the reason why this job is failed? Why this job is failed? So this job is failed because of because there is no primary key. But in the table we can see there is a primary key. Purchase order ID is the primary key. So why this is failed then? So it's because it's not able to generate the boundary query. And why it's not able to generate the boundary query? It's because your code is generated, MapReduce code is generated, but it failed to generate the primary boundary query because your column name is purchase order ID, not ID. So Sqoop, um, uh, when Sqoop created boundary query, so it fit, it guessed that there is always a ID column. But here, because of the purchase order ID, and it detects boundary based on primary key only. Okay, so we can solve this problem using split by. So if we use a single mapper, so there is no need for boundary query because single mapper do the full ingestion. But we never do in the production environment or real environment because it kills the parallelism. Single mapper if is not used for big data processing. Big data is always processed using multiple threads or using parallel threads. So this mapper one kills the whole idea, and that's why this job will be success if I execute using single mapper because there's no boundary query in case of single mapper. Boundary query generates only in the case of multi mappers, and multi mappers is created when there's a huge data and then when parallel processing is required. So see, this time jobs, it's, it's executing and it's success now. So now how to solve that primary key problem? So in order to solve that, we have split by. So you see, records are transferred. You now success this job with the default mappers, or you can say multi mappers. So we can do this using uh, this um, split by. So see this command. So let's copy this here. So Sqoop import and then this connectivity and JDBC MySQL database is MySQL, and then the username, password is Cloudera. Table is purchase, and then the target directory. Target directory, yes, because we already imported. So user Cloudera, and then the purchase. Now this boundary query will implement in the next. So just use this and then do a split by purchase order ID. Now here we are telling Sqoop that we are splitting based on this column, not on the ID column. So it will generate the boundary query based on purchase ID column, not based on the ID. That is the default one. So if I execute this time your job will be success because we are passing a split by. And in the split by, we already defined that our split should happens on basis on purchase order ID, not on the basis of ID. So we will see what kind of boundary query it generates. And this time your job will be success because we defined, okay, file already exists, already exists. Okay, user Cloudera purchase. This one is already exists. So here either we can give a target directory or we can remove the directory. That's the only option. Until so we'll read incremental import, then this problem will be solved because we are doing a full import continuously. So that's why I'm deleting every time. So clean this directory. Now run the job. So now this job is success. So here we can check the boundary query that is generates. That is important. So where is the boundary query? Your data is ingested. See this query. Now this time it generate a boundary query based on purchase order ID. We can copy this and we can execute in our source. And here we can see minimum purchase order ID is 1 and max is 1, and then it do a splits, and based on splits it launch the mapper. So that is the whole concept. Okay. So now if you want to select two rows only or some selective columns, that also we can do. Okay. So just give me a minute. Okay, sorry. So here we need to select, if you want to import selective rows, selective columns. So that also we can do. So here um, in this we can write boundary query, boundary query, and then here we can write the query to select the number of rows. So uh, I just want to import two rows only. We can provide this query here from purchase table. And then if you want to select columns, so just there's a column argument and we are selecting three columns only. The product name, quantity, and price. And if we use single mapper, then it will kill the whole concept of parallelism. So we never use this option. Um, and then split by is required because we have a ID column, and that ID we have a column with a different name, the primary key column. So we need to declare, okay, our ID column is this, do the split based on this column. So it will generate boundary query basis on that. So now we can execute this and we can check it fetch selective rows, selective columns. It failed, why it is failed? Okay, all purchases are already there. Now it's working. So your data is transferred and to verify whether selected rows and selected columns ingested. Um, yeah, this is the directory. Now you can check any of the files. This is the part file. In the file, we can see there are 4 columns only. We have selected these these column only. Okay, so that's how this boundary query concept works. Our next concept is this one is done now. Incremental import. So incremental import. So let's say on day one we ingest 1,000 records, and on day two some more records added in our source. So I just want to import that those particular records only. Let's say 200 records are added. So every time I'm deleting the files from the target, it's because I'm doing a full import. Now, in case of incremental import, we just import the newly added data or the updated data from the source into the target. So now incremental import is of 2 types: incremental last modified, incremental last modified, and incremental append. Incremental last modified and incremental append. So let's implement this. So let's say in my source, where is my source? This employee table. Here I have the 6 records, and this data is already there in the target. Let's verify this. Uh, So this part, using single mapper, we import the data. So that's why it's showing one mapper only. Two records. And this. Let's do import, full import first. So clean up this directory. Otherwise, file system -IMI and this directory. Okay, this one is deleted. Now do import first. Table employee. This is full import. So it's running. Okay, now it's imported. So verify the data. So Sqoop. Okay, now 6 rows are inserted. Now we are adding some appending some record, insert some record in the source system. Insert into employee language. Inserting one more row. Okay, so one more record inserted. Insert one more row. Two records are inserted. Now I want to import these two records only. I don't want to import, do a full import. So these are newly added records. So here we have uh, incremental. This is the case of incremental append. Incremental last modify is for update, and incremental append is for newly added record. So let me execute this command. Um, Incremental last modify. This is incremental import. Hmm. Incremental last modify. Yes. Okay, so your connectivity details. So our database is running on local host. Database is this. Mm, And then the table name. Table is employee. Then split by there is no need because we already have ID column. Now this is important, check column ID. So it do an incremental append using this ID. So it check the column. We need an integer column in the source. So if you see here, this is the ID column and it detects every day. Yeah, every time we are doing an import. So it's check this ID column. And here we are saying do a incremental append. And when we insert last time, so last time our um, value was 105. So this was the last value. and this is not required. And now execute this. Hmm. So now it's doing the incremental import, and it will import the records after 105, because last time when we inserted it was uh, and you see this incremental import based on the ID column. You see here in the logs, lower bound value is this, upper bound value is this. It do import on this range only. This is prior to this, that is already imported. So it's done. Now verify. And you see this time our job is failed. Job is passed. Even if our data is still there. So if we see this employee, so we have two more records, two more mappers that is successfully ingested. That is incremental append. Now, if we update any record, so in the source, we need, it's mandatory to have a date column in case of incremental append, incremental last modified, because based on the date column, it detects what are the changes in the data sets. So you guys implement incremental last modify. This is your assignment for today. Okay. Incremental append I already executed. So that is incremental import. Okay. Now last two topics we'll discuss tomorrow, because here we need integration with Hive. But for that you need to learn what Hive is, and then only we can integrate Sqoop with Hive. Okay. So let me give you a brief overview. Our uh, next tool, or you can say next topic, uh, is in the big data ecosystem is Hive. So we have covered the installation. We have seen the HDFS commands and uh, how we Hadoop store its data in a distributed storage. And we also covered MapReduce, the limitations of MapReduce, MapReduce flow. And now we also learned Sqoop. So how many concepts, you see, it cover a lot of concepts. If you implement these things in MapReduce, you need to write Java code. But it's a wrapper. Sqoop is a wrapper on top of HDFS, not HDFS, on top of MapReduce. Where is the diagram? This one. So that will perform all the activities. And here these commands, this tool is based on these command. So you can say it's a command line tool. So these commands are auto converted into MapReduce and do whatever operation you want to perform. Now the next tool is the Hive. Now, what is Hive and where how we use Hive? So let's modify this. So Hive is again a mapper, or a wrapper on top of HDFS. Okay. So let's put Hive server here. Here is your Hive server, just like Sqoop. And above is Hive client. Now Hive is based on SQL, and we are calling that language is HQL, Hive query language. It's based on SQL only. So we write Hive jobs in SQL. We submit those jobs into Hive server. Hive server convert that job into MapReduce, and then MapReduce process the data or the analytical operation, perform all the analytics operations through this HDFS only. But one thing is important. Hive is a analytical tool on top of HDFS. It's not an ingestion tool. Ingestion is performed by Sqoop. Okay. So when data is ingested into HDFS, now we want to analyze that data. So let's say here this in this directory we have this data set. Now I want to check the number of records. I want to do perform grouping, joining. I want to do a lot of analysis on the HDFS data. So right now we are just blankly seeing this data and checking this data like this. No, this is not the way. We need an interface. We need some query engine on top of HDFS. And right now, these are 6 rows only. If these are rows are in millions or trillions, then how you check the count or how you perform the grouping or doing analysis? We need some sort of tool on top of HDFS that is missing right now. So I felt that time. So um, let me go one architecture. So there's a let's say there's a source tool, MySQL. Your data is here. This is our source. And here we have the target system. Your target is HDFS. HDFS. This is our data lake. Now we can import the data from MySQL into HDFS using Sqoop. That is one way. That is option one. Now there's another way. What we can do, we can ingest that data into Hive. So there's here we need to create Hive table and ingest this data from MySQL into Hive. Now behind the scene, Hive store its data into HDFS only, and it stored its metadata into RDBMS. And RDBMS can be anything. It can be Oracle or MySQL or Postgre or any database. Right now in Cloudera we have MySQL only. So this is the meta store for Hive. Meta store, and its actual data is stored in here. We have the actual data, and its metadata is stored in metastore. So this is another option. Now in both the options, data is stored in data lake only. But here, if we uh, directly dump the data into HDFS, we're not able to query the data. There is no querying tool available here. No querying tool. But when we store the data through Hive, because Hive is a virtual store, its physical store is HDFS only. So once we store the data, so let's say we have here, we are ingesting 1 GB data. So using this process, this is option one, and we are directly inserting into Sqoop. So here it stored 1 GB data in target. Using this process also, the second one, Sqoop is ingesting it into Hive now. Sqoop is doing the ingestion. Now it's ingesting into Hive table, and that data is also going to be stored in this HDFS only. So now HDFS has 2 GB data, 1 GB data directly dumped, and 1 GB data through Hive. So now if we pass that data through Hive, so now we can run a analytical operation or analytical query. So that is the option two is the best option to have. Okay. So that we are going to perform, will perform the practical for this from tomorrow onwards. And so in Hive, what we are going to cover, we'll cover, let me show you. So we'll cover Hive architecture, okay, the architecture of Hive, and then we'll see functions in Hive, optimization techniques like partitioning, bucketing. We'll see Hive joins. So in Hive joins, we have bucket map join, sorted bucket map join. Then we'll see views in Hive, indexing, user-defined functions, variables in Hive, then the various file formats supported by Hive, XML, JSON data load in Hive, SCD techniques in Hive. So these are the topics that main topics that we have in Hive. Okay, and this is the whole concept. Okay, so uh, let me. Okay, we'll start from tomorrow on this topic. So please suggest any good job scheduling algorithm for distributed architecture. Uzi, for this stack, Uzi. We will cover Uzi as well. I will show you how to schedule. So you see the Uzi engine here, Uzi, and this is in the traditional stack. Nowadays, we are using Airflows. Airflow on AWS, we have step function, but Airflow is the best one. So nowadays Airflow, and earlier we use Uzi. So because I will cover this tool as well. Once I finish Hive, then I will show some scheduling. I will schedule Sqoop job, Hive job on Uzi server. Okay. Any question? I'm done for today. Any question or any query you guys can ask. Any question? Okay. So can you share? Yeah, I will share these scripts. Yesterday also I've shared. So these commands I will share. And I think Cloudera, everybody set up Cloudera, or you guys are facing problem? Because yesterday I have shared the link to download. So let me show you that link. Mm, Cloudera to start. So this is the link. You can download from here. If you click on this, it start downloading. Okay, I'm canceling this. So once this is downloaded, you just need to place in some directory like this, and then from this virtual box, you just need to import. Once you import, browse this, it jumps to the Cloudera, and then it will automatically install everything. So if you still face any problem, just let me know. I've downloaded this. Cloud installation is enough for everything. I mean, Sqoop Hive. Uh, yeah, uh, everything is here now. You can see this is within Cloudera only. Impala, Spark, Uzi, Hive, everything is available here. So that's why they have created this tool so that you can learn the concepts. Otherwise, we busy in the installations. So the Sqoop concept, you see how many, these are the development things that we do when we are working on big data projects. So You need to learn the concepts. Installation, yes, one time we do. We learn how a distributed system behaves, but uh, Sqoop is fine. HDFS installation is fine. After that, Hive, Pig, Sqoop, Spark, they all are distributed. So better is to install Cloudera to cover all the environments. Then the document of queries which you have used in. Yeah. So I will share these queries after this session. Okay. Anything else? No. Okay. So we'll see you tomorrow then. Okay. Amar, anything else need to cover? Okay. Thanks. Thanks everyone. Thanks. Bye. See you tomorrow. How we and copy uh, how we copy paste? How do we copy and paste from host to Cloudera? There's no copy paste. You will do a import from VirtualBox. Copy paste from host to Cloudera. Okay. 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 So okay, 1 minute. Let me show you that part. So there's a tool available. Uh, that tool is WinSCP. Download this tool, WinSCP, and install. So I already have WinSCP. Okay. So in WinSCP, just give the IP. What is the IP? I have config 92.68.142. 92.168.1.42. Your username Cloudera, password Cloudera, and now you're connected. So see, left hand side is Windows, right hand side is your Cloudera. So you can drag and drop the files. So let's say on desktop, I have let's say this analysis file. On the right hand side is Cloudera. So you can drag this file into Cloudera. Now it's transferred. Okay. And you can verify on the desktop whether file is transferred. You can see analysis file is transferred here. So this is how we copy the file. Okay. Okay. Rupati. Okay. Okay. I'm dropping off. So we'll continue tomorrow.
Dear participant, I shared the attendance link in the chat box, so please mark your attendance and share your feedback as well. I'm sharing that once again. I'm sharing over Zoom and YouTube as well. I hope all of you are able to access the LMS and we are sharing the required documents in the WhatsApp group as well. So is the same attendance and feedback? Yes, the attendance and feedback link is same only one. Yeah, thank you so much, all of you, and we'll meet you on tomorrow at same time. Bye bye. Have a nice day.